Okay, so you may have already seen my video using the method of renaming mixed numbers as improper fractions when trying to subtract mixed numbers. But this time we're going to do the very same thing using a different process. This time we're going to be looking and using our whole numbers to rename and regroup to find our answer. Just a different way of arriving at the same result. And you get to make decisions about what you'd like to do. So number one, as we always do, we're going to find the equivalent fractions, because it's so much easier to subtract fractions that are equivalent. So what we're going to do is we're going to be writing our equal sign and fraction bars. And then we're going to look at our two denominators, our 4 and our 12, since that's the part of the fraction we want to be equivalent, or I should say to be equal to each other. And we find a common denominator by counting by the greater of the two. So we're going to count by 12s and find one of those multiples of 12 into which the 4 will divide evenly. So let's count by 12s. 12. Does 4 divide evenly into 12? And the answer is yes. So right away we can stop because now we know what our common denominator will be. So to finish that off, we need to finish the puzzle by saying the 4 was multiplied by a 3 to equal the 12. Therefore, whatever we do with the denominator, we have to do with the numerator. 1 times 3 is 3. And so we find our equivalent fraction for 1/4 to be 3/12. Now, the 12 didn't change here, so we can either leave it alone or we can just put in our times 1 because that's what we in fact did. We are not changing it at all, so the 5 times 1 is 5. Now, having done that, it's a little bit of a great deal of numbers squashed into a little space, so we want to get rid of that a little bit. So we're going to scribble out the original fractions. We're going to get rid of them because we don't need them anymore. We have found our equivalent fractions, so we don't need the originals anymore, and they're just having a tendency to kind of get in our way and not clarify our eyes to what we'll be working with now. At this point, we have 7 and 3/12 minus 2 and 5/12, and normally we would be able to subtract, but in this case we cannot, because if I only have 3/12, I can't take away 5/12 without going into negative numbers, and I don't want negative numbers because I don't need them. In this case, I have a whole 7 over here. So at this point, I'm going to regroup the 7. So I'm going to regroup the whole number. And after I regroup the whole number, I'm going to name or rename the one that I'm going to use as I regroup as a fraction. So I'm going to take that 1 from the 7, leave a 6 behind, 6 wholes. But the one that I took, I'm going to move over here. And the reason I'm doing it is because at this point, it's important to me to be able to make the 3/12 a greater fraction than the 5/12 so that I can subtract it. And the only way I can do it is by moving a 1 over. The way that I'm going to do that is I'm going to add that 1 to the 3/12. Well, I could have 1 and 3/12, but I don't want that. I'm going to add it in the form of a fraction. And that fraction is going to be 12/12 because it's very easy to add 12/12 to a fraction that's already got a denominator of 12. So now I can add 3 plus 12 and get 15/12 up here and leave my 5/12 alone because now I can subtract 15/12 minus 5/12. And my final answer here, well, not quite a final answer, will it be? Because this is not in simplest form, but it will be 10/12. And then I'll come over here and subtract my whole numbers that I have left. 6 minus 2 will be 4. Not quite done yet, because even though I just, oops, I'll scribble that out, sorry for that error. Even though I just subtracted, I now have to simplify. And in this case, to simplify, that simply means you have to look at your fractional piece, and you have to look for a number that you can divide evenly into the